Hello everyone, welcome to our YouTube channel, Calculus Hub UPEI Cairo. This video is a part of Chapter 4 in Calculus 1 course, which is titled as Differentiation. In this video, we will learn the derivatives of trigonometric functions and their inverse. I'm Hisham Hosni Hussein, Associate Professor of Applied Mathematics. Please prepare your notes, your pens, and let's go. As clear from the title of this video, we are interested in the derivatives of the trigonometric functions. So starting by the derivatives of the basic ones, sine x and cosine x, how to find their derivatives using the basic definition. Then we can go next to the derivatives of the remaining trigonometric functions. We can go to find the derivatives of sec x, cosec x, tan x, and cotan x using the derivative of the quotient rule. Start by the basic definition of the differentiation. F dash of x equals to limit as h tends to 0 f of x plus h minus f of x divided by h. Okay, so starting by the derivative of sine x. What is the derivative of sine x? F dash here equals to, this is the question now. Step 1 here, we will replace the function f of x by sine x, and we will replace the function f of x plus h by sine x plus h. So sine x plus h minus sine x divided by h. So now expanding this sine x plus h, as we know, sine x plus y, this equals to sine x cosine y plus cosine x sine y. So the derivative will be now f dash of x be equals to limit as h tends to 0. In the numerator, expand sine x plus h to be sine x cosine h plus cosine x sine h minus sine x divided by h. Now to evaluate this limit, we need to split this limit into two limits to be able to evaluate. This is the first limit, sine x cosine h minus sine x divided by h. This is the first one. The second is cosine x sine h divided by h. How come? The first limit will be sine x cosine h minus sine x divided by h plus limit as h tends to 0 cosine x sine h divided by h. We can factor sine x and another sine x as a common factor out of the limit to say that in here we have sine x times limit as h tends to 0 cosine h minus 1 divided by h plus factor cosine x out of the limit, as we are discussing here limit as h tends to 0, but this cosine x is free of any h, plus cosine x times limit as h tends to 0 for sine h divided by h. So limit as h tends to 0 for sine h divided by h is clearly 1 from the identities of limits as h tends to 0. It's clearly 1. So 1 times cosine x will be cosine x. This is the second term. For the first term, for limit as h tends to 0 cosine h minus 1 divided by h. To evaluate limit as h tends to 0 cosine h minus 1 divided by h, we can multiply it by cosine h plus 1 divided by cosine h plus 1. This equals to limit as h tends to 0 in the numerator difference between two squares. It's cosine square h minus 1 divided by h times cosine h plus 1. Cosine square h minus 1 can be replaced by negative sine square h. So the value of this limit will be negative limit as h tends to 0. In the numerator we have sine square h divided by h times limit as h tends to 0, 1 over cosine h plus 1. This limit is 0. This limit is half. So it's 0 at the end. Back again to our original limit. Here we have 1 times cosine x. It's cosine x. Using the same perspective with the derivative of cosine x, I have here f of x equals to cosine x, and we want to find the derivative of this function using the basic definition. So f dash of x equals to limit as h tends to 0 using the basic definition f of x plus h minus f of x divided by h. So here clearly f of x represents cosine x. So f of x plus h, here this would be cosine x plus h. So substituting in the basic definition now, then limit as h tends to 0, f of x plus h, that will be cosine x plus h, minus f of x, which is cosine x, divided by h. But already we know from the identities of the trigonometric functions that in cosine x plus h can be expanded to be cosine x cosine h minus sine x sine h. F dash of x in this case will be limit as h tends to 0. In the numerator we have cosine x cosine h minus sine x sine h minus cosine x. This is divided as usual by h. So splitting this limit again into two limits, cosine x. So splitting this limit again into two limits, cosine x, cosine h, minus cosine h. This is the first one divided by h. The second limit is sine x, sine h, divided by h. So f dash will be limit as h tends to 0, cosine x, cosine h, minus cosine h, divided by h. This is the first limit. Minus limit as h tends to 0, sine x, sine h, divided by h. In the first fraction, we can factor cosine h from these two terms to get cosine h times limit as h tends to 0. In the numerator now we have cosine x minus 1 divided by h. Limit as h tends to 0 for cosine x minus 1 divided by h. Already we proved before that this equal to 0. Minus factor sine x out of the limit. So we get minus sine x times limit as h tends to 0, sine h divided by h. Already we know that in the limit as h tends to 0, from the identities of limits, this equals to 1. So it's 1 multiplied by negative sine x. That will be negative sine x at the end. Another question now is how to find the derivative d by dx for sine inverse x, the inverse function for sine x. Assuming that let y equals to sine inverse x. So affecting by sine for both sides, we get in sine y in the left hand side equals to sine inverse x. Sine inverse x. Sine inverse will be cancelled to get in sine y equals to x. Now differentiate both sides with respect to x. Sine y, its derivative is cosine y times derivative of what's inside, which is y dash, equals to x. What's the derivative of x? It's simply 1. Y dash will be 1 over cosine y. I need the derivative y dash to be represented as a function of x. How can we relate cosine y to x? As we know, in cosine square y plus sine square y, this equals to 1. So cosine y will be root 1 minus sine y square. What is sine y? Already we know that in the sine y equals to x. Now replace the sine y with x. Then cosine y will be root 1 minus x squared, which is y dash. So y dash will be 1 over root cosine y, which is 1 over root 1 minus x squared. What is y dash? Y dash is the derivative of sine inverse x. What about the derivative of tan inverse x? How can we find the derivative of tan inverse x? We'll do the same. Let y equals to tan inverse x. So affecting by tan for both sides, then tan y equals to tan inverse x. Tan will be cancelled with tan inverse to get at the end in tan y equals to x. Now differentiate both sides with respect to x. Tan y, its derivative is sec square y times the derivative of what's inside, which is y dash, equals to the derivative of x is 1. Y dash would be 1 over sec square y. As we know, 1 plus tan square y equals to 6 square y. And already tan y is x. So now y dash would be 1 over 6 square y. What is 6 square y? It's 1 plus tan square y. What is tan y? It's x. So it's x squared. Now, what about the derivative for sec inverse x? Similarly, we will let y equals to sec inverse x. So sec y equals to x. Affecting by sec for both sides. So sec y equals to sec inverse, which is x. Now differentiate both sides with respect to x. Derivative of sec y, the sec y times tan y times y dash. This equals to what's the derivative of x is 1. So y dash will be 1 over sec y tan y. Okay, what is sec y? Sec y is x. The sec y is x. So replace the sec y by x. Now what about tan? As we know, 1 plus tan square y, this is 6 square y. This means that in tan square y, it's 6 square y minus 1. So this means that in only tan y equals to root 6 square y minus 1. What is sec y? What is sec y? This x. So this means that in tan y will be x squared minus 1. Substituting in the form of y dash, so we get in y dash will be 1 over sec y, which is x, times root tan y, which is root x squared minus 1.